Hello everyone, we continue doing combined questions dedicated to vectors, in this case vectors in geometry, the hardest topic for vectors for sure, and that's the set of problems related to hexagon. Pause the video, try to do by round, and let's get started explaining. Okay, so here is the regular hexagon, means six-sided 2D shape. And it's all about vectors. Make sure you remember how to add vectors or subtract them. That's a very necessary skill here. And we need to find in the first question to define vector D. Okay, so I mark vector D in this way. Let it be purple arrow. Okay, that stays for vector D. And that's the first candidate to be found. Okay, so using the head to tail rule, we can say that vector D is simply the vector sum of vectors dB, which is B, and vector A. So that's why we can find that vector D is the vector sum of B and A. So remember, head to tail, we start from the very beginning of B and end up in the very end of a vector of fine vector A. So that's why that's the vector D. Okay, so we know that this side is A plus B, or B plus A, no matter. Okay, so the second question asks us about find vector BC. Okay, where is vector BC? I mark it as letter B pink one, so vector BC. So vector BC is there. So that's pink arrow stays for it. Okay, how to find it? Obviously, we know that we have regular hexagon. However, before doing that, let's calculate the interior angle. I'll show you through this method, because anyway, in question B, we need to find the size of interior angle. That means that you need to have it anyway. So that's why we'll use that method. And for interior angle, we know that each interior angle is actually n minus 2 times 180 n over n. That stays for regular polygon for interior angle. So in our case, we have n equals 6 sides. So that's why each interior angle is going to be 6 minus 2, which is 4 over 6 times 180. Okay? So we can cancel 180 by 6, and times 4 is 120. So 120 degrees stays for each interior angle. So that's why this angle is 60 degrees, as well as this one, right? Okay. Now what I'm going to do, I'm going to just to use the following. I put, using the black, let's say the black line segments, I put from C, I put the parallel line to D, okay? Pretty obvious that if you do the same from the vertex D, you'll have that they intersect in the middle of the side BE, okay? But we'll prove it, don't worry. So we'll prove it soon. Because we know that this angle is 60 degrees, right? And we put C, let's say to the point K, CK, parallel and equal to D, we can say that CK is equal to D, right? And of course, due to regular hexagon, it's equal to BC, okay? So that's why triangle, let's consider triangle BCK. BCK is triangle isosceles, right? So that's why we can say that this angle is also 60 degrees. 60 degrees. So, okay, what about this angle? So, DK is parallel to CB, and it's always equal. So we can say that this angle is 60 degrees as well, okay? What about the top? Automatically, the top ones is going to be 60 due to the sum of the angles. So we have actually two equilateral triangles. BCK is also isosceles and equilateral. okay, lateral. So that means that all sides are equal. And if you mark the side of BC, let's say, as x, so that's going to be also x, and this is going to be also x. On top of that, we know that the rest angle here is going to be 60 to form to the open angle 180. This also 60 degrees, okay? Because that's isosceles, those angles will be equal and they will form also 60. You can check that easily. So actually we'll have three isosceles triangle within this trapezium, okay? That we will need for the area of trapezium in the next point. Okay, but the main interesting fact right now, go back to the vector BC because we need to find vector BC. So now we can freely use the rule for vectors, addition rule for vectors. In this case, I will use other pink colors, and let's say vector BC is actually the result of, just a bit bolder, okay, bold type of vectors. So this is the superposition or the sum of the vector a over 2, yes? So this vector is a over 2, bk. So I can fix these facts so that bk is vector a over 2. And we also add in vector kc, right? In order to get vector bc. So we can write the following equality: vector BC as a result head to tail rule, or using the vector addition using triangle rule for the vectors, we can say that BK and KC together, BK plus KC, will form our vector BC. But BK is a over 2, so this is a over 2, and on top of that we need to add vector kc. But hold on, kc is the same as vector ed, right? Because we put it parallel and equal. So that's why we found de. So de from the previous step is simply a plus b. But our vector kc is negative d. So we can say that kc is simply negative de, all right? So that means that here stays negative a and negative b. So that's how we can find vector BC. Not finding those angles, not proving that BK is a over 2, it's not possible to prove that. I mean, to figure out vector BC, except for using their brilliant idea, which saves you time, I'll tell you right now. So this is the principle of symmetry, so that we put CK and DK, and due to the symmetry, they need to be inside in the middle point. So K is basically the middle point of the segment B, okay? Due to the principle of symmetry. So if you write that on exam, that will work, but it's better if you can prove it that using just simple basic knowledge of triangles. So that's why finally, if we write the final expression for BC, we simplify a over 2 minus a is going to be negative a over 2 and negative b. That's the final expression. So that's why BC is simply negative a over 2 minus b. Okay, we fix this result, okay, and then we go next. We'll go to the next slide. So we completed A. In case if we need to have reference, so we have it here. So now what about B? The size of the interior angle of the hexagon, we proved that interior angle is simply 120 degrees. The area of the trapezium ABF, so ABEF, it's right there, okay? But as we notice, BEF trapezium equal to BCDE due to the principle of symmetry, because BE is the cross section, so that splits your hexagon on 2 equal areas, okay, on 2 equal trapezium. And we are going back to the reference that this trapezium consists of 3 identical triangles with a side of 10, because we're given in this case side of 10 for the regular hexagon. We can state that the area, so BII, The area of the trapezium, I put this sign indicating that we're looking for the area of trapezium, okay, is equal to 3 areas of equilateral triangle. And instead of triangle, let's take triangle BCK, okay? Area of triangle BCK. If you like, I can just put here so that for just simply for convenience. And let's drop that color. That's good. So here, 3 identical triangles, and all sides are equal. That's the picture that you'll have. So everywhere 10, 10, and 10, okay? So that's why, how to find the area of BCK. If you have the angle 60 degrees, as we proved before, so area of that triangle is simply using not the height, 1/2 height by the base, but we are going to use a bit different formula, 1/2, two sides 10 and 10, because that side CK is also 10, okay? So that's why we'll get 10 times 10, and times sine of the angle in between them, sine of 60 in this case, okay? So let's calculate 10 by 10. It's going to be 100/250, and sine of 60 degrees, sine of 60 degrees is simply square root of 3/2. Square root of 3/2. So that's why the area is 25, okay? And if you multiply it by 3, you'll get 3 times 25. Square root of 3. So finally, you'll get 75 square root of 3. So that's the area of their trapezium. So area of trapezium is 75 square root of 3, okay? So next part, I, the area of hexagon. So B, I can be found the area of the hexagon. Hexagon is simply double the area of each trapezium. Have a look at the picture. So that's why we just doing 2 times 75 square root of 3. I leave in third form, but if you like, you can calculate or compute it using decimals. 150 square root of 3. And we completed that one. So 150 square root of 3. And finally, you need to find diagonal of the trapezium ABEF. So ABEF. I'll switch to another slide right there. And let's consider trapezium, the bottom one. And we plot the diagonal from A to the point E. So that's going to be the diagonal of the trapezium, and that's what we need to find, okay? So the diagonal of the trapezium is going to be X. So we mark that as X, let it be X. All right, so we need to use definitely triangle ABE, okay? ABE. We need to categorize which type of triangle we are given. But let's have a look first onto the sides. So this side is 10, right? This is the side of regular hexagon due to the conditions, due to a statement. And B, as we proved before, is going to be twice, right? BE is twice that the side of CD or BC, no matter, because that equals to that and equals to other sides in their equilateral triangles. So that's why here is 10 and here's 10. In total, we have 20. So that's why this side is 20. We know two sides, 10 and 20. And what we can say that the side, it's too early, of course, right? Because we need to say which type of triangle. But I bet that this is 90 degrees angle. Let's have a proof. So 120 degrees, right? This is interior angle. Triangle is an isosceles, AEF. So that's why sides are going to be each by 30 degrees. They share evenly 60, right? The rest 60. Okay, so that's why 30 and up to 120 will definitely have angle of 90 degrees. in order 90 and 30 will give us interior angles. So triangle is a right angled. So that's the case, and that means that the side 10 should be twice less than hypotenuse, right, opposed to the angle of 30 degrees. So this angle is 30, and we can definitely say that we can use different ways, but we know if it's 90 degrees angle, so what we can do, we can find using Pythagoras. That's the quick way. Or trigonometry. So using Pythagoras, we'll get x squared plus 10 squared equals to 20 squared. Okay, so from there, x is square root of 300. Or if you simplify this third, you'll get 10 square root of 3. If you like, you can check using trigonometry, so trig ratios. So you're given 10, right? And you want to find x. So no matter which way you use that, but let's say, okay, you have hypotenuse 20 and you would like to use 30, okay? So that's why side x is simply 20 times cos 30. So 20 times cos of 30. Cos 30 is square root of 3 over 2. So that's why finally you'll get 10 square root of 3. Okay, so that's an idea. Hope you like that. Don't forget to subscribe if you're new here. And don't forget to rate this video. Please like. And of course, visit A-Level. Zillion's classes. And don't forget to check also my videos dedicated to A-Level stuff if you're an A-Level student and doing recap from GCSE particular topics. That was Daniel Dallas. See you next time.